Welcome to another episode of Coding Things. This time I created an AI that is trained to shoot a target with precision using a genetic algorithm. In college, I became fascinated with genetic algorithms, and I've always wanted to create one that played a game, but I've forgotten almost everything about genetic algorithms. So what is a genetic algorithm? In the most basic explanation, it simulates natural selection and evolution to solve complex problems. The first example I learned was called Shakespeare's monkey, where a monkey with infinite time and a typewriter will eventually write all of Shakespeare's works. So let's start with that example. We need to follow a few basic concepts to implement a genetic algorithm. Starting with variation, I need to generate a large population, and in this case, a large population of strings made up of random characters that I'm just going to call phrases. Next is selection. I need to select the best phrases, but how? Fitness. I calculate the percent of characters in the correct spot within our phrase, and now I have a population with a fitness score. Moving on to heredity, I need to create the next generation of phrases, so I need to add phrases from our current generation into a mating pool. There are a few ways to do this, but my favorite and probably the easiest is tournament selection. For every phrase, I randomly select the phrase, excluding the current one, and then compare the fitness. The phrase with the higher fitness gets put into the mating pool. Next is reproduction, where I do a process called crossover by simply picking two random phrases from the mating pool. Then I create a child calling the mate method, where in this specific case, I get a random midpoint and take one section of a parent and combine that with the last section of the other parent. The final step is mutation. I check if each character should be mutated. If so, I just change it to a new random character. And now I have a phrase to be or not to be, where we can watch natural selection take place and eventually writing, well, it might help if I actually create a new mating pool for each generation. Eventually writing the sentence. There we go. Cool. Let's do this again, but with a small game. In this game, I created a cannon that I can aim, can move, adjust the force, and shoot a cannonball at a target. The goal of the genetic algorithm will be to hit the center of the target with some precision. I need some way to calculate the path of the cannonball. So I found an article with some fancy maths and I implemented that, but it's kind of broken. So I came up with a look-back system where I do a raycast from the current node to the previous node to check for a collision. If a collision does occur, I do another raycast from the previous node to the current node to get the hit point on the object we are colliding with. Now I can start on the algorithm. Just as before, I started with creating the population of cannons. Now I can calculate the fitness of each cannon using the trajectory script that I just worked on. It looks complicated, but it's actually pretty simple. After I calculate the path, I return true or false if we hit the target and out the exact hit point on the target. Based on that hit point, I calculate the fitness by getting the distance from the center to the hit point and then dividing by the max distance. That's not right. Let me just go back, use the calculator. Right. I'm just dumb. Okay, now that I have the fitness score working, I need to evaluate the population. For now, I grab the most fit cannon, check if it hit the center of the target, and set up the necessary logic to show the top cannon shooting using some flags and delegates. Once the top cannon shoots, and I still need to do crossover, then I'm gonna find parents starting with tournament selection. So I'm just gonna copy from our phrase example, blah, 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 and boom, we have tournament selection again. Now that we have a mating pool, we do crossover, but instead of characters, we have three properties: position, rotation, and force. And of course, we mutate the child, where I make a check against the mutation rate. So real quick, you may have noticed that this logic is really flawed. Yeah, I didn't notice this until I was writing the script for this video, so more on this later. And then I grab a new random value within the given range for each property. Finally, I added a bunch of logs to prep for debugging the many errors that I know I'm gonna have. 1 second. Okay, let's see what errors I get this time. Honestly, I'm surprised it's working right now. Now I'm gonna sprinkle some magic UI stuff. And while I'm here, I'm gonna implement the wheel selection, which just means I'm very confused about the logic I just wrote, but according to this article, it's gonna work. And I'm going to pretend it's working. I finished the UI, but I'm still not satisfied. So I added the top 10 cannons to the scene. Well, okay. I added the top 10 cannons to the scene. And this platform is really boring. So let me make it pretty. All right, that's better. I need to fix something. If you remember, I interrupted and pointed out an obvious logic error that affects the mutation rate and is probably the cause of the genetic algorithm being pretty bad. While I'm here, I'm going to add some obstacles to the scene so that the AI has something to work around. Okay, yeah, let's just see what happens and then make adjustments from there. Cool, 15 generations. Let's see what a larger population size would do. 3 generations, okay. So that's pretty easy, I guess. Let's just add obstacles, make it a little bit harder for you. Let's just start it and see what happens. So 39 generations. What happens if we increase the mutation rate just by 0.5%? Small adjustments. 49 generations, it didn't really help. But you can see that it is working around the obstacles, which is pretty cool. Okay, let's mess around with wheel selection and I guess keep everything the same. And let's start without any obstacles because I feel like wheel selection is broken. So yeah, let's see what happens. So I do notice a large slowdown, which I think I know the problem, but I don't want to admit it. Okay, 95 generations. I'm gonna just taking a lot longer. I'm gonna decrease the min-max force so it has less to work with. I'm going to give it a bit more leeway, lower the mutation rate, see what happens. Okay, giving it a bit more leeway, obviously, it's gonna help. Okay, I'm gonna stop it. I'm gonna go back to 0. Keep most of this the same, but I really want to see how many generations it takes. So I'm gonna start it. I'm gonna step away, come back and see what happens.
2 very boring minutes later.
All right, I'm calling it. I notice it's slowing down a lot. It should not be this slow. I'm gonna stop it. And out of fear, I'm going to open up my task manager because I think I know what the issue is. Oh, what the f